Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.
We're going to do a bit of a workshop today. Our agenda for today is, one, I'm just going to do a little bit of an intro about what is Orchestrate, who I am, why we built Orchestrate, just go over our documentation, client libraries, and give you a tour of the API. And like I said, you're welcome to follow along. I'm going to be using HTTP-Py, which is a really nice HTTP querying library that's very similar to curl written in Python. Yeah, so my name's Ian Plosker. I'm the CTO and co-founder of Orchestrate. Before Orchestrate, I was at Basho Technologies. Does anyone know Basho? They make a database called Reoc. No. Well, Reoc is probably one of the more interesting NoSQL databases on the market right now. It's kind of in the same, it makes similar trade-offs to Cassandra. It's much more robust than, let's say, MongoDB, but and a lot more scalable. So, in a lot of ways similar to Cassandra with a slightly different data model. Anyway, in the process of building and selling Reoc, we learned some interesting things. One was that, well, it's kind of obvious, but that databases are built to solve particular problems. And very quickly, when you're building sophisticated software, you find that one database doesn't solve your problem because you're building something on MySQL, but then you need full-text search, and now you're bringing in full-text search. Then you realize that, oh, I really want to take advantage of graph querying, and next you're installing Neo4j. And if you work in a large organization, that involves a lot of different steps, including operationalizing it, bringing team members up to speed, training your DBAs, training your DevOps team. It can get quite expensive. So what we did is we built Orchestrate. And Orchestrate is a service that replaces databases. So it's a database as a service, but it provides a broad swath of query types. Everything from key value to full-text search to geolocation, graph, and time series data. And we've done this by combining a number of different databases, each suited to the particular workload, and built a really nice HTTP API in front of it all. And what this allows us to do is take the queries you're making and apply them to the right database for that particular query. We handle all of the difficulties of replicating that data between the data stores, deciding which data store is appropriate for which query, and providing that really great, highly available uptime. So, which is quite hard, especially when you have multiple databases involved, because each of them has its own operational characteristics. So it's an API, it's a REST API, it's JSON in, JSON out. You can kind of view it if you wanted to. A simplified explanation is Orchestrate is a searchable document store as a service. Anyway, so like I said, our query types are key value, full-text search, time series, graph. It says the future is geospatial and large objects. Actually, we haven't documented geospatial, but it's in there. And we'll try and mess around with it a bit. What's really nice about running a service is you can sneak features in without people noticing. And then once you document them, people become aware of them. So anyway, just in terms of where our service is deployed, as you can imagine with a database, latency is quite crucial. So what you want to do with Orchestrate is locate your applications as close to Orchestrate as possible. Right now, we run Orchestrate in one location, which is AWS US East. We're going to start running in AWS EU West in Ireland, so that should be coming later this month. And we also operate dedicated deployments of Orchestrate in whatever data centers you want. So if you want a private deployment of Orchestrate, we do that. In addition, we're working on replication right now, which would allow you to replicate, let's say, between US East and EU West and use both of them in a master configuration or from your data center to a public cloud deployment. So that's data locality. And let's just go ahead and get started. There's tons to cover with the API, so I don't really want to mess around too long talking about talking about Orchestrate itself. You'll understand it much better once we get started. All right. So first off, to get started, we need to go to our dashboard. Let me see. So if you're following along, you can go to dashboard.orchestrate.io. Let me just sign out quickly so you can see. You can sign up here and follow along if you want. I don't actually know my password, so I'm going to pull it out of 1Password and get going. Oops. So, all right. This is the Orchestrate dashboard. This is basically the center of your experience with Orchestrate. This is where you go to provision applications. What is an application? Application is the unit of tenancy. It's the unit of isolation. It's, should map roughly to an application in, whatever application you're building. So today, let's start a new application called APICon UK 2014 and go. So one of the things you'll notice, and this is something that differentiates Orchestrate from almost every other database as a service out there, other than maybe DynamoDB, is provisioning was instant. And why this is Orchestrate is a truly multi-tenant service. We're not just taking instances and charging them for you. You don't have to worry about scaling. Most of the other databases as a service out there are really offering just help operating a database. They still require you to decide what sort of instances you want to use, how many, how you want to shard the data. Orchestrate completely eliminates all of that. So our application was provisioned instantly. We can see on this application page that we can add team members to collaborate with, create and revoke API keys, and we can also start creating collections. So what are collections? Collections roughly map to a table in a relational database. These are sort of your, are the containers for all your different data types. So for today's example, we're going to build a kind of mock social network. I think, whereas with Ruby on Rails, the canonical example is a blog, with Orchestrate, the canonical example is a social network because we provide all of the particular features needed for a social network. So just to quickly go through them, key value for storing things like user profiles, search for discovery, graph for describing relationships between objects. I'm friends with this user, I belong to this group. Time series data encapsulates things like status updates. I did this at this time. Geospatial allows you to say, I'm here, or I did this there. So those are really all of the important verbs associated with a social network. So let's go ahead and create our first collection. We're going to create a users collection. Now, everything we're doing from here on out, you can do from the API itself. So I think now is about time to cross over to the API because we could actually query Orchestrate from the dashboard and it provides some nice tools for getting started. But really the depth of the API you can only understand from actually getting at it. So just as a note, if you go to docs.orchestrate.io, you can learn all you need to know about our API, including, oops, that was an accident. Sorry. Including how to query with all of our first-party clients, Node.js, Ruby, Python, Java, Go, and there's examples of how to do each query in all of the various languages. So if you want to follow along in a different language and use, like the Ruby REPL or the Node.js REPL, you're welcome to do that. So let me just grab my API key and get going. All right, let me get this positioned in the center of the screen so we can all see. All right. So for those of you who don't know HTTP/PI, it's very similar to curl. So first off, we're going to need to pass in our auth token, our API token. Orchestrate uses uses basic authentication over SSL to secure data. So all your data is sent over SSL, so it's all encrypted. Your API token both identifies who you are and what application you're trying to query. So next up, we just need to put in what sort of request we want to do. So let's just do a GET request to our API /v0, and let's hit the users collection that we just created. Now, sorry about that. Well, it worked. We see actually that we did a query for tell me what's in the users collection, and as there's nothing there, we get back no results, an account of 0. So let's actually just go ahead and put our first user profile. So I'm going to change get to put. Can you guys see that all right, or should I make it bigger? The first line's cut off. Slide that over a little bit. There we go. All right. So, actually, give me 1 second. I want to make sure that everyone can see what I'm doing. There we go. Perfect. Ooh. And then I'll just run another get so I can clear that out of the way. Perfect. All right. So let's do a put. One of the nice things about HTTP PI is that it doesn't make you write janky JSON strings. I hate writing JSON myself. I think people talk about its advantage being that you can easily read it, but it's very difficult to write, although XML is harder. So let's create a my user profile. So one of the things we can do is we can just treat this as a hash map and we'll automatically convert it into JSON. So first off, I'm going to create a field called name, and I'm going to put my name in it. I'm going to go ahead and set my age. Oops. And it will detect whether things are strings or integers. And let's set our location, or my location, to London, UK. And we can go ahead and we get a 201 created, which is what we hope would have happened. Now you'll notice the HTTP response headers we get back. There are a couple of them that are worth noting right now and we'll get back to in a little while. So first up, we have typical content type, date headers, not so important. We have an E-tag header. Is everyone here familiar with E-tag headers? For those who aren't, E-tag headers are typically used to identify, are used for caching. They're used to identify what version of an object. They're usually a content hash. So this is the content hash of the object we just stored. And next you actually notice something that's a location header. This is a little bit more rare, but what a location header says is when you do a put or a post, a location header will be returned to you to say the canonical location of the thing you just created is here. So yeah, those are really the important headers. Let's go ahead now and actually just try and get back this same object. So again, we're going to go to api.orchestrate.io, API version 0. We're in the users collection getting the object keyed in. I didn't mention that. Orchestrate is a key value store, so all of your objects in a collection will have a key. You can either pick your own keys or Orchestrate will allow you, or will generate keys for you if you don't want to select keys yourself. In fact, our key generation is kind of cool because we have a distributed key generation algorithm that guarantees that keys semi-sort. What that means is that keys will generally sort in insertion order. Can't guarantee that it will be absolutely insertion order, but near insertion order. Anyway, let's go ahead and retrieve our key. Boom. So, of course, we got back the JSON object we just stored. Again, you'll see the E-tag header matches and the content location matches. So why these are important, why I keep pointing them out, is Orchestrate has some interesting properties. One is that all data in Orchestrate is immutable. What that means is that no data ever gets deleted. What happens when you change a value, so let's say I went back and I just got rid of the location field. Okay, I get a 201 created. Now I query Ian again, and look, it changed. Well, yes, it changed, but we have this content location header that has the canonical URL for this value. All keys in Orchestrate are actually time series, and when you query that key, you're just asking for the head value. But all of the previous values that that key has held are still available. So for example, if I wanted to see all of the values that have been held in this key, I can go to user/ian/refs. Refs are that reference history. It's the history of all the values that were there. And we say values equal true just that we can see the actual values, not just the URLs to retrieve them. And boom, we see that there's actually a time series here that's returned in reverse chronological order. So we see the most recent value at the top and the value that it held before coming up next. So even, for example, if we issue a delete to this key, now if we went and we queried the key, we look for the head value, we get a 404 not found because you deleted the item, the most recent version is deleted. But if I want to go back in time and see all of the values that have been held, I can actually see that. So we see that there's actually a count of 3. The first item is a tombstone, which means that it represents a deleted item. It makes sure that when I query the head, I get back a 404, but I can see all the previous values as well. Does that make sense? Cool. I'm going to recreate this key so that we can do some interesting things with it. Now it's set back to the original value. Let's go ahead and create a couple more users just so that we can make this a bit more interesting. So I'm going to create a user for each of my co-founders. So actually, let's see. Okay, so I'm making an object for my co-founder Tony. I'm going to make one for my co-founder Matt. Oops. I can't type, of course. All right, perfect. So now we have a couple objects created in this collection, and we can do some interesting things. Now you notice the first query we did was just a get to the collection. When you get from a collection, all it does is it lists the items in the collection in key sorted order. So this is actually a really nice feature. Very few key value stores actually allow you to just go and say, give me back all of the keys, distributed key value stores, I should say, give them in key sorted order. So you can see first Ian, then Matt, then Tony. This will automatically get paginated. In fact, you can set limits. So let's say you would never actually do this, but let's say you set the limit to 1. Now you get one item. You can actually see that in the JSON response, there's a link to the next page as well in the HTTP response header. There's a link to the next page of items. So you can see, basically you can set additional parameters, like show me everything after a particular key. So let's get rid of the limit. So we can say, I want to see everything after a key Ian, or it could even be a non-existent key. I want to see everything after the key I. And that will actually return everything because Ian is sorted after I. And I could even say something like, and before key T. Now I should only get 2 items back. I should only get Ian and Matt. So this is meant to allow you to do interesting things with key naming so that you can get back ranges very easily. So for example, if you were using date timestamps as your key, you can take advantage of these to let yourself query time ranges. So those are just for simple sorts of key sorted queries. But let's say I want to do a full text query. You promised, or I promised, that you could do some full text search. So full text search is super easy. I don't know how many people here have experience with Solr or Lucene, but it can be a bit of a pain to get started with Solr or Lucene, given that you need to set up schemas. Elasticsearch, which is a really nice tool, claims to be schemaless. Anyone who's used Elasticsearch for any length of time knows that it's actually the complete opposite of schemaless. It infers schemas and then binds you to the schemas that it thinks you want. And very often those are not the schemas you want. So Orchestrate is actually truly schemaless. You can have completely sparse data in a collection, and Orchestrate will treat every object being stored as a completely separate object and creates a separate schema for all of them. So when you can put data with non-matching fields. So, actually it turns out I didn't mean to do that, but our age field ended up being a string. It really should have been an integer. Should I store something with an age field as an integer, a proper number? Orchestrate would be able to handle that. Elasticsearch would vomit on that. Anyway, let's just do a simple query. Let's say I want to see anyone whose name starts with M-A-T. So anyone whose name is Matt. I can just go query with name equals Matt, and perfect. I get Matt back. Let's say I wanted to see anyone whose age is between 20 to 35. Now I get back Matt and Ian, so I can do range queries. Let's say I wanted to do that query, where a range query, but I wanted to do something nice like sorting it in descending order. I can say sort the age field in descending order. Now you notice the sort results end up reversed. Typically, Orchestrate returns values based on, or returns search queries based on relevancy. So we'll show you the most relevant result first. For it to, in this case, the score for both objects is 1, given that they're equally relevant because they both fit in the range. But for example, if you had a bunch of ors such that, in your query, so you said age 20 to 30, or, the name starts with Matt, let's say, you'll notice Matt comes back more relevant. It's scored higher because it matched 2 of those clauses in that query. Does that make sense? Awesome. So, Orchestrate search features, I'm not going to demo them now because it's a pain in the ass to know latitude and longitudes, just pull them out of nowhere, but you can actually do geoqueries. We haven't documented this yet. We're going to have a big launch with this soon, but if you simply created a field, let's say that location field was instead a JSON object and had fields inside of that object called lat and long, those would be searchable with geoqueries, where you can actually say, show me all of the objects in this radius or in this polygon. So the way you would do that, for example, let's say that location field contained lat and long. You can do location, then you say near, which says that you'd like to do a geoquery, and then you can say with lat, latitude of, what are we? We must be 51 or so, is that right? In London, 52, something like that, somewhere in there. And longitude, somewhere slightly negative right now. Yeah, a little bit negative. Anyway, you can provide those, and Orchestrate will do that, and then you can provide a radius, and we support a bunch of different things. You could say 1 mile or 1 kilometer, and we're pretty smart about detecting if you typed radius or longitude or lat or whatever you want. We'll try and figure out exactly what you meant. But yeah, that's basically how you do geoqueries. So that's search. Before I move on, does anyone have questions about search?
I have a question stepping back. So I'm following along. I'm using the same URL as you, except for the key. So how does it know to go to different data stores? I don't get the same results.
Well, because you have a different API key than me, correct?
Yes.
Yeah, so that's how. The API key identifies who you are and what application you're querying. So that determines how to route your query to the correct.
But the resource that I specified uses something I typed in.
Yep.
Is it just a coincidence you have the same one?
Yeah, so it is essentially a coincidence. Under the covers, I mean, those resources are only relevant to you. Basically, the resources are sort of isolated based on API key. So, yeah, did that make sense? Any other questions before we keep going? So the other thing I didn't get into, and maybe if we have some time later, I want to show more of the API features, but very common question with key value queries is, so great, I can update keys, they keep a history, but what happens if I have multiple API servers? I have multiple, I have multiple applications accessing the same database and potentially writing to the same key at the same time. How do I coordinate those requests so they don't write on top of each other? We provide optimistic concurrency control using standard HTTP caching headers, if match, if none match, and there's documentation on that. So basically what you can do is when you make a query, you say, here's the last ref value, the last version I saw. Only allow this update to succeed if the version that you have stored matches the version that I last saw. So if two actors come in, they've both gotten a key, they're updating it, changing, incrementing the age field or whatever they might be doing, and they both go to write, one of them will succeed and one of them will fail, assuming you use those headers. So it allows you to sort of optimistically attempt the request and fail only, the one of them. All right, so that's search. So let's go ahead and move on to graph quickly, because that's quite simple. So what graph allows you to do, is to describe relationships between objects. So basically, what we can do is, let's say I wanted to say that I am friends with Matt. I can go to our users collection, the key Ian. I can go to a special URL, a special resource called relation, and with the relations, I can give them a type. So I'm going to say that I'm friends, because I want this to be, I'm going to have multiple friends. You'll see why you want this to be plural, though it could be singular. I'm friends with users/Matt. I'm just going to put this relationship with no value. And I get a 2 of 4 no content, meaning that it was successful, but there's no relevant information to return. And to make this interesting, I'm going to say that I'm friends with Tony as well. And to make it even more interesting, I'm going to say that Matt is also friends with Tony. Great. So now we have a small graph. Obviously, graphs can get more complicated. As you notice, you have to specify, fully qualify the collection and key, so you can actually make relationships between collections. So assuming we had a collection, called groups. I messed this up. Member. We had like group and orchestrate founders or something like that. I could create this. I'll just execute it so you can see what happens. It gets a failure. It says, oh, group orchestrate doesn't exist. You need to create it. But yes, you can create relationships between different collections. So let's go ahead and, well, first off, we're at Matt anyway. So let's go ahead and query Matt's relation. So now you say plural relations / friends, excuse me. And this will return, still a put, excuse me. This should be a get. Perfect. So now we got Matt's friends, which are only Tony. Matt obviously isn't that social a guy. Let's go ahead and query for my friends, because I have more friends than Matt. We can see that my friends are Matt and Tony. And even more interesting is I can, start traversing this graph. You can say, who are my friends' friends? So we go to user/ian/relations/friends/friends. That's friends of friends. And you can see that Tony is a friend of my friend because Tony is friends with Matt. I'm friends with Matt, and Matt is friends with Tony. So Tony is a second-degree friend. And Tony doesn't have any friends. So if I want one more degree out, we'll get back no results. Is that clear so far? Any questions about graph?
Yes, so does it mean that you use different database for storing the relations in the backend, right?
So we don't quite use, so just to talk about technology a little bit, I can repeat the questions. The question was, do you use a different database for graph? So sort of. We use really 3 databases to build Orchestrate. HBase for key value, time series, and graph, but each of them are we built sort of purpose-based schema design and sharding designs for those particular problems. So for example, key value data gets broadly spread around our HBase cluster, whereas time series data gets co-located based on, you'll see how it works, based on the context that it's created in. Graph data is stored such that we can easily traverse data so that related nodes are stored near each other so that it's quick to query and traverse. So for search, we use Elasticsearch, which I criticized a bit before. Elasticsearch is great. It's just some of its promises around schemalessness are a little bit not fully realized, and we've done some work to make that true. And the other database we use quite extensively is MySQL, because there's nothing wrong with relational databases when you have relational database problems. So those are the 3 databases we use, and like I said, we basically have tailored our our data models to each of those databases and to the particular type of query. So does that answer your question? Any other questions before I move on?
So is friends a built-in feature, did you say?
No, those types are arbitrary.
Okay.
So you can call it whatever you want. It just allows you to describe exactly what the relationship represents, that you can have different types of relationships. So we call them types or kinds. It's, it's from your application domain.
Did I miss you building that type, friend?
Yeah, it's implicitly defined when you create a relationship of that type. So like when I did this put here, that's like, user/Matt relation friend, that defines it, or friends, yeah.
Thank you.
So if I could change this to, frenemies, for example. I don't know if that's how you spell frenemies. I don't actually know how to spell frenemies. But yeah, then you would do that. Then, that type exists. So yeah. All right. Any more questions, or you guys want to see some time series data? Let's hop into time series. So, what have we done so far? We've done key values, so we can do our user profiles. We've done search, so we can do all different kinds of discovery. You can even do some sort of kind of graph features with search. So for example, you could just list in my user object all of the groups I belong to, and if you wanted to discover the groups that way, if it fits your querying style better, you can obviously do that instead of using graph. But there's search, there's graph for dividing the relationships between objects, and finally we need ways to actually say what we're doing, because that's pretty much the most important aspect of modern social networks, telling everyone what you're eating. Let's go ahead and within my user object, in fact, within every object in Orchestrate, there's sort of this sub-collection, this time-ordered sub-collection. It's kind of like relations. You go to events/events, we can define a type for the event. So let's call it what I ate. and we can say I ate, I don't know, a banana, for example. So you can imagine this being sensor data, for example. So, the reason why our time series data is sort of embedded underneath key value objects is because things happen in context. When you have time ordered data, you need to define a context for it. And it allows you to define what, the querying context for it. I'm going to query this data. I'm going to pull it out, with this other time series data. Oops, I did a get, not a put. So I got a 200 OK, but that isn't what I want. I want to, sorry. Messed that up. I want to do a put, or actually it's a post, not a put, excuse me. I don't know if you guys know the difference between a put and a post in HTTP parlance. The big difference is that a put is idempotent, and what that means is if you repeat it a million times, you have the exact same thing happen every time. A post is not idempotent, which means that the state of the system changes with multiple calls to it. So given that that when you're creating time series data, it's ending up keyed based on timestamp, you need to post, because each time you post, it's going to create a new item. Whereas with a put, you would expect it to keep writing the same item over and over again. Great, so 201 created, I ate a banana, I ate an apple, let's say, I ate, I don't know, a cherry, and so we have a couple of objects created, and now we can just go to my events and see, oops, again, I need to keep forgetting to change the verbs. Perfect. So now we've gotten back our time series data. So 200 OK, and the headers aren't that interesting in this instance, but we get back a count and we get back our results. So let's take a look at one of these results specifically. We see something called an ordinal, which actually this field's being deprecated because this is actually going to be in the path object. So the path object, all queries you do to Orchestrate will always return a path object. And a path object gives you all of the details describing how to find this object. So it's in the user's collection with key Ian. It has an ordinal of some really, really big integer. We'll talk about an ordinal in a second. It has a ref value. The ref is a content hash. We sort of talked about this before, that defines the version of an item. We have the timestamp of when it's created. And you'll notice that it was returned in reverse chronological order, much like a user timeline. And type what I ate. Again, this timestamp field is here for backwards compatibility, but is being deprecated. And then we see the value itself, the one I created. So we see cherry, apple, banana. So this ordinal field is a bit interesting. It's a bit technical why it exists. But essentially what the ordinal field is it's a field that tells us what order the items came in. You can actually put an item to a timestamp. You can define your own timestamps when you write an event. But what we need to differentiate is, let's say you put two events to the same timestamp. We need to be able to determine which one came in first and which one came in second. Ordinals are what allow us to do this. What ordinals are is they're a value that's guaranteed to monotonically increase. It always goes up and never goes backwards. So each event is guaranteed to sort in the order it came in, even when it's within the same timestamp. So I can give you a specific example. So let's just take this timestamp here and use it a couple more times. And let's remember, this time we're going to do, I guess again, it's a post actually. It is possible to do a put to our event API, but you need to define more things to do a put. So I don't know, I ate popcorn, and I ate, I don't know, a plum. Great. So let's go ahead and, well, we'll just do a get again. So what you can see is it's sorting. Now we're going, as we scroll up, we're going in chronological order. Banana, popcorn, plum. That was the order we inserted them in, but they're all inserted to the same timestamp, so we can actually differentiate which one came in first. That's the purpose of ordinals. In fact, you can use ordinals. If you sort events, you can actually see the order the events came in, not just based on their timestamp, because you can assign any arbitrary timestamp you wanted to an item. In fact, one interesting thing to note is you can see that I wrote this timestamp, or this timestamp is a Unix timestamp, but you can actually just use a ISO 8601 timestamp, which is a standard format timestamp, and let's say I'll just insert it to 924, not define anything else. I ate peach. Oops, that event parameter is invalid. Oh. I think I actually need to provide a time. Let's just try and do midnight. Otherwise, I'm just going to fail at this. And you'll just have to take my word for it that this works. No, failure. It is possible to do this. I just don't forget, or excuse me, I forget the format for doing this. All right, it's certainly in our documentation. In fact, I will quickly pull up the documentation so I can see the timestamp. Put, I want to delete. There's put, update, no, we want post, create, timestamp, optional. I know there's information on this somewhere in here, but besides the point. Read the documentation. You can use other timestamp formats. In fact, I just don't know them offhand. So a bunch of different timestamp formats. All of these query types for pagination, by default, we only return 10. You can request up to 100. If there's more than 100, we always return headers to allow you to do this. So just quickly, if I set the limit to 2, we'll see we get back 2 items, and we can actually see the next page. So you can see actually how you can do range queries using these headers, because you can say before event time at slash, that other thing is an ordinal, so we actually know exactly which item it was after. And let's insert this back in. We can get the next page. And there's still another page. With events, it only shows you forward pagination. With search, it also shows you reverse pagination. So you'll see the previous page if you're actually offset into results. You can see how many existed previous to that. So that's events. Any questions about events? Yeah?
I guess it maybe applies to probably more to search, but you could use it. Can you specify other ways of sorting things?
With events?
Yeah.
So there are some places in our API that we need to expand. Events right now do not get search indexed. That's something we are adding support for, and once we do that, sorting will be part of that, because everything that's search indexed is sortable. Although I will say one restriction of sorting is if you have a giant blob of text, we can't really sort on that because it's a giant blob of text. You're not going to compare all of those. Sorting actually needs to be done in memory. So we basically, I think what we do, when we do this, is we extract the first certain number of characters to be used for sorting. But yeah, that will be added. I know that that's something that we're working on now, is getting search added to our events API. In fact, we'd also like to extend the graph API so that those graph edges, you'll notice, don't actually have properties. It'd be very nice to be able to say this friendship actually to be like a key value object with a creation date and some metadata. Maybe you'd want to say where we met, and then be able to search those relationships. That's something that's also we're going to be adding, but not there yet. So yeah, in fact, sorting, it's great being able to show it because sorting was something that took us almost 6 months of work to add, and it seems like such a simple thing. It's actually an incredibly hard problem if you've ever taken this on, because essentially what happens when you sort data is all of the results for an index need to be brought into memory and then sorted. So if you have 10 million items, all 10 million items need to be brought, for the field you're sorting on, all of the field values need to be brought into memory, sorted, and then you retrieve the first n documents and then do that repeatedly. We did a lot of work to optimize that and make sure that tenants couldn't blow up the entire sorting service. So it's, I think that kind of shows what you get when you use Orchestrate, is you don't run into problems of, oops, I did a sort that caused an out-of-memory error on my search servers. So, yeah.
And when you paginate,
Yep.
are you paginating through a live, this is what's there, or actually through a data set at the point when you first run a query?
Okay, so we're going to get into some complicated things quickly, but I think this is worth it. So I'm going to back up and then sort of answer this question directly. I hate talking about the CAP theorem, but it's happening. So basically with databases, you have to trade off in distributed databases whether you want to, in the case of some sort of failure, either maintain consistency or availability. Orchestrate on the key value side maintains consistency. So if we run into a failure, certain keys will be unavailable. That being said, we have SLAs. I think our SLA is 99.95 for all customers, and it's higher for enterprise customers. I don't know offhand. It doesn't really make a difference. But search results, just given the way search works, is eventually consistent relative to the canonical key value data. So when you write to Orchestrate, we make sure it gets persisted into the canonical key value store, HBase, which gives us really strong durability guarantees and consistency guarantees. And then it gets replicated to the search store. So no matter when you're doing a search, you should assume that it's a little bit behind. Then once we do a search, we do keep the results of that search in memory for a little bit of time so that we don't need to rerun an expensive search. That being said, depending on how long you take to request the next page, say you have a user paginating through things and they leave the page up for 30 seconds, it's very likely that the entire search is being re-executed. So answer is it depends. It's eventually consistent, and in some cases it will rerun the search, in others it won't. Generally, that's sort of the trade-off you have to make with search systems, is they're not going to give you a sort of consistent picture of the world.
Would those be cached across different API keys that you generate for your own install, or would it be kind of separate?
So it will be cached such that if you make the subsequent request over the same HTTP connection, assuming you've kept alive your HTTP connections, which is just, good behavior, it will try and do that. So we sort of make an assumption, which may not be the best assumption. It's kind of hard to do that, assuming you go to the same API server, which means generally using the same connection, that it will, be cached there. Otherwise, I mean, the response times are pretty low in terms of how fast we can do search queries. I mean, average search query, is returned. I need to check the stats today, but it's on the order of 10 milliseconds. So it's big deal if it reruns. It's saving you 5, 10 milliseconds, and typically search data is going to an end user. So it's hundreds of milliseconds where things make a difference with data that's going directly to users. So I think I'm pretty short on time. I can maybe take one last quick question, if there are any. Otherwise, I'll hand over the stage. You guys can track me down. We have a booth here in the vendor hall, and ask us any questions you want. Otherwise, just quickly finishing up, we do have a free trial. It's 1 million requests per month. So as 1 million requests for free. We just charge based on API calls. If you do more than that, basically it's $2 per million API calls. We are changing the pricing soon, so I recommend, if you are interested, that you lock in that pricing now, because the pricing is going up, not down. So that's it. I really appreciate your time, and again, seek me out if you have any questions.
Brought to you by MuleSoft, provider of the industry-leading AnyPoint platform for APIs.